So here I've got an empty sweet tin. This is actually a metal one which you might find lying around at home. I'm going to place a 5p coin on here in a moment and release it from this position. I've used a couple of bits of blue tack to fix the tin and check that this line is vertical. So I'm going to put the 5p coin on the edge of the tin here and I'm going to release that, and what you can see is that the coin moves in contact with the tin but then leaves the surface of the tin. Our task is to predict the angle at which the coin leaves the tin. I'm going to start by using the principle of conservation of energy. The coin starts here where the speed will be 0 and it leaves at this point with a speed v. So at this point we have 0 kinetic energy, and here we will have a half mv squared. That will be equal to the potential energy lost, which will be mg times the change in height. Relative to the centre, the height here is r cos 15, and here the height will be r cos theta, where theta is the angle between the radius and the vertical when the coin leaves the tin. So that height will be given by r times cos of 15 minus the cos of theta. So we can show that v squared equals 2gr cos 15 minus cos theta. I'm now going to consider the forces acting on the coin when the radius from the centre to the coin makes an angle of theta with the vertical. Resolving towards the centre of the circle, I have mg cos theta, this angle here is also theta, minus r, that's the resultant force, and that must be equal to the mass times the acceleration, which will be v squared over r. When the coin leaves the tin, r will be equal to 0, so we have mg cos theta equals mv squared over r, or v squared equals rg cos theta. Now we can combine the two results. From the conservation of energy, we had that v squared was 2gr cos 15 minus cos theta, and from applying Newton's second law we had that v squared is equal to gr cos theta. The gr's will cancel out. This simplifies to 2 cos 15 equal to 3 cos theta, so that cos theta equals 2 cos 15 over 3, which gives theta equal to 50 degrees. I've now added another line which makes an angle of 50 degrees to the vertical as predicted by our calculations. So now let's have a look and see what happens. That all happened very fast, but it did look like a reasonable result. Now I'm going to show it to you in slow motion so that you can see for yourselves more accurately.